Hello Internet, welcome back to the world of Zero Arcade. We're changing things a little bit. So when I initially demoed this project, we were doing what I was calling Sumo Splash, which was like a platformer fighting game thing. We're kind of going away from that, mostly because it wasn't working as well as I wanted, and it was due to the latency. There's a lot of things that you have to account for, and fighting games are it's really important for timing. So to keep the game interesting, it was very hard, and it was very hard to get actual community interaction into the game. I was struggling to get that actually in. So we're changing things. We're going to be doing sort of a geometry based game. So I've got a little square here. This is just done with a line render, and we're actually going to be working on that shortly. But what this is doing is just drawing a square. This is going to be your player. And so the number of sides is going to represent your health. So a triangle would be 1 health point left. This would be 2. And as you add additional sides, that's additional life that you have. And so then you lose when you're out of life. So the basic idea here is we're going to be able to send all sorts of other enemy shapes at this one. And it's more or less going to be not so much a bullet hell, but more of just an arcade shooter thing. So things are just going to blow up and it's going to look really pretty, I think. I'm still not super sure about how this is going to turn out. There is the latency issue is going to affect whatever game we choose. So I'm trying to find something that's really exciting and fun to watch, but also has the community involvement that we're going to need for this kind of game, and works with the latency. So hopefully this will do it. What we're going to be working on specifically is we're going to be building out this dynamic shape render. So we have a line render. I've already kind of shown that. What we need is we need to be able to draw any amount of shape. So we can change this from 3 up to 32. This is all, I just kind of set this up beforehand. The idea is we want to connect that and actually have it draw. There are some caveats to this. There's 4 points on this square. So we need 3 lines, or 4 lines actually. So we can go all the way around. That means we need 5 points, but I actually have 6 here. And the reason I have 6 is because if I get rid of that last one, you can't really tell, but we lose a little bit right where it merges. It becomes more obvious the bigger I make this. So we're going to the center point of this, and that's a problem because since it hits the center, these two don't line up. We could fudge these numbers a bunch. So like if I did, this one would be 0.55, and then we could change this to be negative 0.55. And we'd get roughly the same. That may actually be the solution we take. But either way, we need 5 lines in order to go here, or 5 points to go from here, down to here, and then back to the original position. So our goal is to make this work. So what we're going to be focusing on is actually dynamically being able to create these shapes. And that's what this dynamic shape render is. I don't want to have to be able to specify, or how to specify all those points, and I want to animate how those points appear. So we can do some like soft body stuff with all of this. So we're going to implement this guy. And so all we need to do is be able to, for a given object, we need to generate a shape for it, which is fairly easy because all of these are going to be just basic geometric shapes, which means all we need is pretty much a radius, and then it's just really a circle calculation. So the points, we're just going to store them as vector 3s, a vector 3 array of our points. I don't know what I want to call this, so we're going to call it our vertices. Sure. So we're going to probably add more to that. It's probably not going to be just the point. This will work for now, but we're going to want to update that. And so I'm going to do a bunch of really bad stuff just to get this started. We're going to create a new vector 3 that's going to be equal to our points plus 1. And remember, this is so we go all the way around and then wrap back to the beginning. So if we don't go back to the beginning, there will be a hole at wherever the bottom is. And then all we need to do is for int I equals 0, oh my god, I cannot type. There we go. For I less than the vertices count. So for every vertices length, every single video I seem to be struggling to type. What is this? But all we need to do is iterate over all these points, and we're going to effectively go around a circle. So the way you calculate this is cosine is going to represent our x, and sine is going to represent our y. And so that means 0 is going to actually be directly right, because that'll be 1 on cosine and 0 on sine, and then it'll just kind of go and wrap around. Don't know the dimensions of this, so we're going to have to play with that. But we're just going to do x and y, and just solve for those, and then set the vertice of whatever index we're working on to a new vector with x, 0, and y. Is that right? I don't think that's right. We're gonna do it anyway, because I'm trying to mirror what I already have. This way we kind of, yeah. And so I think what we're doing here, no, we're using world space. Why, what? Oh, we are, okay, so our camera's above. Got it. Our camera is above looking down. Sorry for the chromatic aberration, I just have that on. I have a bunch of image effects on, but it's actually warping all of the Unity gizmos. That I wasn't expecting. But anyway, that's a thing, so yay, I guess. Anywho, we have this here. We need to get, that's our other project. We need to get our vertices working, and I just screwed everything up. There we go. So this creates our vertices. It kind of wraps around, but we don't actually do any points. So let's do our math cosine of I. So I'm just going to take the index and multiply that by however far it is to go around. So we're going to divide that I by a float of the total number of points, which will be the total number of points to get around a single circle. And then we need to multiply that result by whatever it takes. So this is radians. So to get around a circle, it's 2 pi. So math 2 times math f dot pi. So effectively, these two values are separate. And so we're taking the total number of, we're taking a fraction of how far around the circle we've gone, and then we're multiplying that by the total size of the circle. So this will create points, number of steps around a circle, and then that should just be able to be plugged in. So what we could do, and what I actually might do, is force this. So vertices of the vertices dot length. So we're going to take the last point, so subtract 1 off of that, and set it equal to the vertices 0. And so what this does is it forces the two to be identical. So they're at the exact same point, which this should accomplish anyway. But as we start, like if I start adding additional forces and have like some smoothing or something, this will make sure that they evaluate to exactly the same. Okay, I think that's all we need. So this will create our points, set them, and then we just need to set line render dot points Set positions, sure, to a set of vertices. There we go. And that should be enough to update our line render. So I don't have to deal with this actually running in-game, I'm just going to update this so that we have execute in edit mode on. And I'm going to initialize our radius to be 1. So that'll just make sure that it at least starts at something. It actually wasn't something we had considered, so I'm going to plug that in, which is really easy. We can actually just scale our vector, actually. That'll probably be easiest. So just take our xy vector and scale it by the radius. That gets us a scaled vector. And then we can just plug it in. Cool. Oh, it's gone. They're all 0. We do have 5 points. Oh, why is it set to 1? There we go. That's not exactly what I had in mind. Oh. I don't think we're scaling our number of points correctly. Yeah. So the positions.size is not changing. So we may actually have to set that manually. I was thinking it would come with setting these positions, but apparently that's not the case. So set num positions. Set the number of line segments. We're going to set that equal to our vertices dot length. And that should solve at least part of our problem. And this is getting updated every update, so we should see something happening. So one of the things that I'm confused about... Oh, I didn't, did I? I totally... Yep. That explains why it was going back and forth linearly. We were just making a line because we were plugging the same function in. I'm sure somebody was sitting there going, no, don't do this. This isn't going to work. It wasn't going to work. So we have to plug sign in for the y. And that should get us our shape. And now it should work. Yes. So this is a 3 shape. And as I increase this, you'll see we do get that little gap there because I didn't extend this. But what we are getting is starting from this origin, we're getting all of our points. And they work pretty well. And this is more or less just a circle at this point. And we might be able to enhance it a bit to not have so many segments, but it works. So we have a more or less basic line render. It's working. I don't like this bit. So what I'm going to do is increase it by 2, I think. So this actually needs to be a -2 now. And this needs to be a -1 and set it to 1. So we're doing that extra wrap. So if I go back here, normally we're going up here, or down, across, and then we'd stop here. That would be the final point. Now we're taking it one step further and actually stepping up here again, which is not a great idea because it adds that extra geometry, but it solves our issue of actually closing this, and it should solve it regardless of how big we make this. So even though we did add that extra geometry, but now we don't get that seam, even if we go far higher, which we would if I was trying to solve this myself. So it seems like a good trade-off. I don't know if it actually is or not, but I don't think I don't think rendering is going to be what's going to hold us back here. So we're going to go with it until it doesn't work. All right, that's more or less what I wanted to cover, but there's more. Since we've got a little bit of time, this one's running a little bit short, so I'm actually going to modify this a bit. This is probably gonna bring it way beyond. So if you guys want to tune out or come back or whatever, we are going to be focusing on actually animating this. So we're going to create a new inner class. Don't know if it's going to stay here, but we're going to call it a dynamic vertex. And so these are going to have positions, relative positions to this model. So we're going to have a vector 3 of our vertex. We're going to make this public, like so. And we're also going to have a speed, I want to say. I don't know if this is a good idea, but effectively it's going to be at some point, and we want to move it towards the vertex. So it's going to have a vertex, and we'll give it a target. Okay, so we have a vertex, we have a target, and we have a speed. So the vertex is going to move towards the target at a speed, which means we're going to want persistence. So this doesn't work. Which means we have a public points exposed there, and vertices exposed there. I'm going to make this private, and I'm going to make it out of dynamic vertices. So dynamic vertex, and we're actually going to have a private points as well. Vertex points. And so this is just going to track our actual points. This is going to be what we're actually going to care about. And if these two values are different, we have to regenerate our shape. So the other thing I'm going to do is plug this into a linked list. So we're using a linked list here because we're going to be adding and subtracting from this a lot. And a linked list is going to give us constant time for that. And we don't really care about finding specific points. We just care about more or less finding the point. So we're going to do a new linked list of dynamic vertices, like so. All right, so we have our linked list, and we need to update this. This is now incorrect. We need we're going to use vertex points from now on. So +2. Do we need that? No. So this is going to exist here, but we're going to actually have to generate a separate set of points for this. So we're going to have vertices here, and then that hack we had to actually kind of wrap around, that's going to be separate. That's only going to happen when we do the draw. So this is actually going to be generating the points in our thing. That it's actually going to be moving those around. So we need to create it at vertex points. Is this correct? Vertices dot add last. So we're adding something to the end to actually adjust for this. So this is only going to work once. So every time we update this, it's going to play the animation from the start, which isn't ideal, and we'll have to probably. No, I think actually we can probably. I think we can adjust for this. So we're going to start at points. That'll work, and we're going to do I plus equal to the sign. So this is kind of gross, but we're going to take the sign of our vertex points minus our points. So points is going to be where we are going. So this is wrong. We're going to take our points and subtract off our vertex points. So vertex points is where we are. It represents the total number of vertices in our list. So I can actually delete that and move it down here. So we're going to have an int vertex points equal to the vertices dot count. So it's just a shorthand for that. And then we're going to increment by the sign. So it's either going to return plus or minus 1 of this value. So if points is greater than our vertex points, so we're trying to get more points onto this, we're actually going to add things. If our vertex points is greater, on the other hand, this function actually gets negative, so we're actually taking things off of it. So I may actually want two separate things for this. Yeah. Because, so, oh, yeah. So this works only if points is greater than that. All right, so I think we're gonna have to split this up. I don't think this is gonna work all as one. It'd be cool if it did, but I don't see that working. Not well, anyway. So what we're going to do is this is going to be our add. So actually, it might work. So we're going to add here. So our vertices, this is not right. We have a total number of points here, and we want to get 2 points. So while it's less than that, just increment and add the new points. So we're just starting partially through our server. So the cool thing with this is it's actually these points are already gonna be in a specific thing, so it's actually gonna shift all of them. So this still doesn't work. Sorry, I'm getting the, yeah, that won't work. We need to start at I, int I equals 0, and do a for each. Sorry, this is getting more complicated than I had anticipated. I haven't done this before. So in for each vertice, we need to go through this and take the point and update it. So we need an I plus 1 here, or plus plus here. So we're going to increment the I. We can do that later. And then we need to take the point and set its target equal to this new vertex. And so the reason we need to do this is because if we don't do this, it's not going to work. Because otherwise everything will create like a triangle, for example, and then everything else is just going to get slightly smaller. So it'd look cool actually, because it'd do like parts of things, but then all the new attributes would be kind of added incrementally onto the end, and it just kind of get more and more precise near the end. That's not what we want. We want it to kind of smooth itself out. And so this should accomplish this. What it's going to do here is update each of our vertices to have a new proper position, and then for int, oh my god, this is going poorly. Actually we can just leave that. Can we? For I equals the total number of points. So for I is equal to the vertex points, we are going to want I less than our points, and we're going to want to increment on that. So we're incrementing here, we're starting from the last point, and then we're going to count up, and we need to add that many indices. So we're going to do a vertices dot add last, so we're adding onto the end with new dynamic vertices. And so we don't need to change anything. All we need to do is take the last point in our linked list and use it here. So we just need a copy of whatever that is. So that's exactly what we're going to do, is take our vertices dot last, and we're just going to take the value from that and take each of these. So it'll start at the last point, and it will kind of automatically animate backwards. And so this is going to actually prevent us from like randomly spawning something in the middle. We're going to rely on that animation to solve that for us. So I need to just pull all these over. Dot last value. Let's take the target. There's no constructor here, so I can kind of make this on the fly. We're just going to do speed next. Sure. Can I? Yeah. Create constructor. Cool. And that should not. Okay. Fine. Don't make it for me. This dot vertex equal to the value vertex. Oops. Vertex. And then we just need to set each of these. So pull our target in. Like so. And also our speed. And that should solve that. So we now are creating a new vertex with almost the same. It'll have the exact same as the. Or do we want last or first? I think we want first, actually. Sorry about that. And I'm taking the target here, but we don't actually want that. The target is going to be different. So our target is actually going to be this new vector 3 of x, 0, y times the radius. And keep in mind, changes to the radius aren't going to regenerate this, so it might look a bit funky. But we can deal with that later, as always. So this should automatically increment things and actually build up. If we get rid of things, this code should still work. So this code is going to automatically loop us over that, so it will just create a bunch of extra things. The only one we care about is this, and this is only going to run if our points is greater than our vertex points. So we already have that condition covered as well. The only thing we have to consider is for the vertices, let's do a while, sure. While our vertices, that's not how I type that, dot count is greater. So while this is greater than the points, we're going to want to remove the last element. Dot remove last. Oops, yeah, there we go. So that's just going to pull things off the end. And the position would have already been updated here. So it should all work. Everything should be good up to this point. We should have all of our vertices and everything working. We're not doing any animation yet. And we're doing it every frame, which is gross. We can change that. This should only fire if it's changed. And it, for the most part, it will, but we can make that better. So what we need is we have all of this code down here, which is actually taking our vertices. We can actually get that out by doing a, that's actually using our vertices. That's not going to work. We're going to need a separate array for this. Oh, this is gross. So we're going to actually just have a vector 3 array. That isn't how you do vector 3 arrays. We're going to call it our render list. Sure. We're going to create a new vector 3 array of vertices plus 2. Vertices.count plus 2. So it's going to be equal to the count plus 2, just like we did here. So everything there is going to operate exactly the same. The only difference is we need to actually plug that in now. Like so. And so this should actually more or less work. Oh, except that. The only difference is this is now empty, so we need to fill this. And we can do that with an int I equals 0. And we just need to iterate over our vertices.count. It's a linked list, so I'm actually going to do this a little bit differently. I'm going to have an I here to keep track of the index, but then I'm actually going to use a for each so we can actually take advantage of some of those linked list thingamajigs. Because indexing into linked lists is really slow. So we've got our variable of our vert, sure, in our vertices. And what we want to do is set the vertex, actually. Just to make sure this works, actually, I'm not going to use the vertex, I'm going to use the target. So we're going to have our render list at I++. This will just increment our I. And we want to just set that equal to the vert.target. And that should just keep everything up to date. I'm going to use n here because we already have I above and we're already writing bad code. So this should just render pretty much exactly the same thing. We shouldn't see any change in this. And we get an old pointer. Object reference not set to the instance of an object. Which I believe will happen if we start adding from nothing, which is going to always happen because we don't persist this. Duh. Duh. I should have known that. So let's do that. Let's create that. And then I'm just going to add first, add last. It doesn't really matter. We just need a new dynamic vertex vector3.0. I'm just going to initialize these to empty values, and then we'll give it a default speed, so they all have the same speed. But the rest of this does not matter because it's going to be updated. So the only thing that's going to change is this initial position is going to have some effect on how this would look if we animated it, but we're not there yet, so it doesn't matter. So we should get something that looks like this, or not. 42. Vertices.count. We may be getting this issue because start, I don't think start is called. So yeah, cool. So we can subtract and add, and it works just like it was previously. So final thing I want to do is animate this. So all of this code, it's in our update. Actually, all of this code is in our update, but I'm actually going to extract that or not. Where we want to extract. Refactor, extract method. So this is all update. It's going to update our vertex list, sure. So that just pulls all of that code out. All it's doing is making sure everything is connected. So that's all good. We've got that out of the way now. So all we need to do is after we update the vertex list, we need to for each var vertex in our vertices. We need to update its current position. So we're using target here. I'm going to update that to use the vertex. So where it is, let's actually rename that to position. And that way it just aligns way better. Go for it, sure. So now everything it aligns with like a transform, what that would be. So what we need to do is actually move our vertex dot position towards the target. So we're going to set that equal to vector3.lerp. So one of the tricks, this is probably a really bad idea, but we're going to do it anyway. Vertex dot. So what you do is you plug in the position to like a lerp function. So you do, the position is going to be equal to the lerp of that position and the target. So if we plug that in, vertex.target, And then as the speed, we use the time delta. If you do this, is there an editor? Sure. Time delta. So time, okay, sorry. Delta time. Got it. Confusing myself. So this is just going to move it towards that. But what it's going to do is it's going to do sort of a Gaussian blur between the two, or not blur, sorry. It's going to do a sort of a blend between the two. So what it's going to do is it's going to find a position, but it's going to effectively calculate a line between the two, and then based on that line, it's going to put a point somewhere along it. And where it puts that point is based on this. So by providing the time, we're doing a very small step towards it. But that line keeps getting, the length of that line keeps getting shorter and shorter the closer and closer you move. So the percentage you move, because this is effectively a percentage, gets shorter and shorter the closer you get. And so it kind of creates a fall off effect, a natural fall off, which I think looks fairly good. One of the issues with doing it this way is it's very difficult to actually get it directly to that point, but I don't care about that, so it's fine. And so it should, if I'm correct, automatically update our thing. So we're still getting null pointers. That's because the start didn't happen. So I'm going to actually start this. And you can see it grew there, which is cool. That's what we want. And as I remove these, as I remove them, you can see the vertexes start kind of shaving off. And it actually looks really, that's actually super cool. So one of the things that I kind of would like is I would like when we remove, I'd like that line to kind of break off. We can do that later, but this is cool. I like that. We need more of that. So we've got a triangle here, and then I can increase that, and we get some weird fancy growth, and I can delete a bunch of them. And so we have effectively we're creating a polygon, a normal polygon that is growing over time, and we can adjust that by the slider, and it all happens in real time. And we can do this with a ton of shapes. So if I create another one, we get that cool concentric ring thing, which is neat by itself, but then I can move it somewhere. Why can't I move it somewhere? Oh, ha. So there's one issue. Oh, it actually is running in the editor. That's interesting. I wasn't expecting that. So does this actually... Yeah, okay, that's super slow. And it's not really gonna actually work. Some things have to trigger this view editor to re-render. Otherwise, it's not going to actually do it. So the frame rate here is actually way slower than it would normally be. Like if I start dragging the camera around, it will redraw. But you can see it's stopped now. So it's not going to actually do anything until I start doing things. And you can see there's massive time spikes. Like the animation doesn't look smooth. That's just because of the way the editor tries to save your computer from dying horribly in a fire. So we need to make this line render use world space, or not use world space, sorry. So I should be able to move this now. Yes, cool. And we can move it and we get that nice chromatic aberration. I can rotate it because it's just a childed object. I can rotate it. We can do whatever. And yeah, we've got fancy, cool resizing rings that we can do whatever we want with. It's not playing, so that's not going to work, but you get the idea. So, I don't know, I think this is cool. If there's anything you guys want to see, anything else you want to do with this, let me know, because this is going... I didn't really cover what the project is. I've kind of covered it in the past, but we're making a game for Beam, which is a streaming platform that offers really low latency. So the idea is you will have a controller that you plug into this to actually control your main player. And it's all going to be played over stream. So you're not going to have the game locally. You're going to look on a stream. You're going to have a controller either in your browser or on your phone or wherever. And you're going to interact with this game. So that's sort of where we're going. It's a long way off. I'm hoping to get it done in like a month or so, or at least have a demo up within a month. We'll see. There'll probably be a lot more coming out later in April. For the most part, the game itself, I'm going to do just on my own. It's just a really classic shoot 'em up, and there's not much point. There's plenty of tutorials on that, and I'm not sure I'd add anything. But if things like this come up that are really, I think, are really cool, we'll probably cover them in more detail. Or if there's just something you guys want to see, let me know about that so I don't skip over it. But yeah, this is where we're at right now. I'm going to make this move around and do all sorts of cool stuff, make it shooty, and then add some enemies and do a bunch of other fun stuff. And then hopefully you guys can play it. So that's where we're headed. But that's it for now. So until next time, see you, Internet.